So, Clint, it is great to be here. Here we are at a real live event, Amazon reMARS, all about, machine learning, AI and automation, robotics, but we're here to talk space.
Space.
So it's great to see you. Thanks for
good to be with
here.
you.
I mean, my gosh, I've seen space suits, I've seen spacecrafts, sat through a couple cool keynotes, and
Great.
it's been amazing.
Great. That was the idea. The idea is we're trying to tee up all the things that AWS is doing to support and enable and help grow and innovate across the space industry. So terrific. I'm glad you saw some of that.
Absolutely.
Yeah, it's so exciting to have you here with the 6.5 on the road here at Amazon reMARS. By the way, just thrilled. First time reMARS for myself. And,
Me too.
Done the reInvent show, and that's awesome. But this is awesome in its own way. Like I said, tip of the spear, coolest, geekiest, furthest out there, future forward technology, and the keynote's just overwhelming. Let's
Great.
get to you.
Great.
I want to learn about you. Clint Crozier, AWS. Tell everybody about your job, yourself. You spent like 30 plus years in the military. Just give us the background. So much for everybody to know.
I know you've had other guests tell you this before, but I'm going to tell you I have the coolest job in the world.
Wait a second. I thought I did.
Maybe it's a tie. So 33 years on active duty with the U.S. Air Force. I had the wonderful pleasure of being the lead architect and lead planner for the stand-up and creation of the U.S. Space Force in the last couple of years of my career. So 33 years flying satellites, launching rockets. I've done everything from fly satellites to command entire bases, Buckley Air Force Base in Denver. I had the opportunity to command the GPS satellite constellation at one point in my career. Everybody in the world has used GPS one time or another, so that was a lot of fun. And then as we got the Space Force up and running, I had this tremendous opportunity. As I announced my retirement, there's one thing I knew. I wanted to stay close to space. And then Amazon called and said, we've got a great idea. We're seeing the rapid growth of the space industry, and we know our cloud computing tools can really infuse innovation into the space industry, and we need somebody to help make that happen. We need somebody who can help the space community understand the untapped value of the cloud in space. And so that's the job that I was able to get, and that's what I get to do every day.
So AWS is all about the cloud.
Yep.
Clouds are in the stratosphere.
Right.
What do clouds have to do with space? You hinted at it a little bit.
Yeah.
Can you talk about
setting them up?
Why it's in there?
Yeah. So this is such a perfect marriage, and it really is. So my whole career, flying satellites and launching rockets, for my end, right, I'm on the operational end of the mission. For me, it's all about the satellites and the rockets. And as much as I hate to say it, it is not and has never been all about the satellites and rockets. It's all about the data that comes down from the satellites and rockets. And so we're living in an environment today where we're going to have a 10x increase in the amount of data coming down from space in the next 3, 5, 7 years. Petabytes and petabytes of data coming down. More data, frankly, than we know how to manage. So how do you manage that data, collect the data, store it, analyze it, move it around, disseminate it, make useful insights in real time of it securely? And it turns out that's exactly what the cloud is good at doing. So the cloud offers a perfect solution to the challenges the space community is facing with managing and organizing and leveraging these large volumes of data coming down from space.
It's incredible.
Yeah, there's so many applications, and I sit there and I start thinking in my head all the possibilities. And of course, and you're going to talk more, we're going to get to some of the things we saw in the keynotes, future communities in space, and that of course is going to require all the same data center technologies that we have here on Earth. But, a job like yours is really large. I know we had a little, behind the scenes time together the other night.
Yeah.
And so I'm a little more informed than maybe everyone out there at what you're up to. But as we started rattling off use cases, you're like, wow, there's a lot of them, a lot of different things.
Yeah.
But I'm guessing right now, just to try to convince the market, get all the, get people to buy in. You got a fickle society right now that has mixed emotions about space.
Yeah.
What are the areas that you feel you can dive into, focus on right now and get a lot of value and start to prove this idea of bringing the cloud to space?
Yeah, well, what I really love about AWS is that they have given me and us, our team, all the resources we need to meet our customer requirements. So as long as customers keep leveling requirements on us, we're continue to grow our business. And so we've grown a lot in the last 2 years since we've stood up. But the good part of that is whether it's a company that's using space and cloud for space exploration, and we do a lot of that, and we'll talk about that, or whether it's one of these companies that I like to say our line of effort is focused on making the world a better place from space. So whether it's applying space to the agriculture industry or the maritime safety or the mining or even wildlife management and climate control, we've been able to assign experts across all those missions who can help those space operators and space entrepreneurs figure out how to use that space data for those values.
When we had our dinner a couple nights ago, you talked about things that could be done in space, making maybe some drugs, and also, like you just mentioned, growing things there.
Yeah.
Why is space a better place to do that to help Earth? I was thinking, okay, these would all be done for people who might have to live out there.
Yeah.
Right? But can you do a drill down, maybe give an example of that?
Yeah. So as we think about this, making the world a better place from space, which I love, I'm very passionate about that. But let me run you through a couple of use cases. So we're working with a company right now called EXI out of Australia, and they're using space data to identify the outbreak of wildfires in remote parts of the Australian bush within 3 minutes of ignition. So when you think about wildfire management, if you can identify an outbreak within 3 minutes, and that applies not just in Australia, but everywhere in the world, think about if you can vector a crew in within 3 minutes of ignition, vice 3 hours or 3 days. And so that makes a huge difference. We're working with a company called Gatehouse Maritime out of California that's using satellite data to monitor the migration patterns of whales and report to shipping vessels when whales are migrating through the shipping lanes, right? So think about that. We're working with companies that are focused on food security. Digital Earth Africa moved their AI/ML capability to the AWS cloud, decreased the time it takes them to make predictions about food security and crop health by 800%. And they're using that to identify areas where crops aren't getting enough water, where pests have invaded in the crops, and where they can posture food relief forces and capabilities. So the use cases are just amazing. You talked about medicine. So those are a number of ways we're seeing space being used here on Earth. But the other thing that's really interesting is there are experiments going on right now in space and
like right now. This is
right now in space, medical research on the International Space Station and others, where because of the unique properties of microgravity, they're able to do things with cancer research that they can't do on the ground. They're able to do DNA sequencing a little bit different than when we do it under gravity. And so whether it's manufacture of new vaccines and new medicines, and we're working with a company who tells us that they believe they can manufacture fiber optics in microgravity, which would have a 10x increase in transmission capacity than fiber optics developed on the surface of the Earth. So the use cases that are being looked at about the kind of things you can do is just amazing.
Wow, I'm imagining a silicon fab in the sky here. So
so you heard Orbital Reef. Blue Origin talked about Orbital Reef, and they are building Orbital Reef right now today. Axiom Space is building a commercial module to the International Space Station. Both of those companies have the vision of building a commercial park in space. And so you could envision manufacturing satellite parts in orbit. Think about satellite servicing. My whole career, when you launch a satellite into space, there's nothing you can do once it's on orbit, right? If one of the solar arrays breaks, you're done. Now, if you have a station in orbit, you can manufacture solar array replacement parts, send a crew or a robot out to the broken satellite, fix it on orbit, and avoid having to launch a new satellite from the ground or dispose of or burn in on entry the satellite that wasn't working. It's powerful what we can do.
Yeah, I'd like to step back just a sec. We had the favor of actually learning about Orbital Reef for the first time. I know you had talked about it before, but can you tell the audience what you've been working on? Let's say probably the three cooler things until we get into your announcement.
Okay.
The Space Accelerator,
Yep.
Orbital Reef,
Yep.
and the third one was even Mars.
Yeah.
And let me just interject really quick because I can't get this fab in the sky out of my head. I just want to
Yeah.
paint that picture for everybody that's
Yeah.
out there. Like
Yeah.
the Millennium Falcon, up in space, or like where's Darth in this
Yeah.
whole thing? But but seriously, like
On-orbit satellite repair will be huge, right? The cost of putting a brand new satellite from Earth into space is enormous. It's coming down, but it's enormous. Now, think about if you can manufacture either satellite components or parts or manufacture entire satellites on a space station in LEO and then deploy them into space. It would be a hundredth of
the distance.
the cost.
I mean, so this is where basically his question's going. Though, it's like the distance between Earth and every single time you have to launch, it's huge.
Well, so
could you take the intermediary.
Here's the analogy: shipbuilders don't build ships in the desert and then port them to the sea. They built them on the coast and then launch them into the sea. It's the same analogy. We're building satellites in the desert today and launching them to the ocean. We don't want to keep doing that. And these orbital habitats like Axiom and Blue Origin Orbital Reef, they will allow us to do those kinds of things.
So far, we've talked a little bit about Orbital Reef, which I thought was amazing when I saw the mock-ups for what it was. It literally looks like, it reminded me of 2001: A Space Odyssey.
Yeah, we have a setup. We have a VR reality, augmented reality hub set up downstairs where you can put the headphones on and you think you're in the Orbital Reef and you get to walk around and see what its life is going to be like living in space.
So would you do it?
I would, absolutely.
You get on the list because some of the stuff's like pre-selling. I think it's
would.
important to point that out. Like, one of the most interesting things I learned yesterday, listening to you and your counterparts at Amazon talking about Orbital Reef, though, for instance, is I think a lot of the world kind of thinks this stuff is happening like this is just prototype, future speak. Like,
it's happening right now.
It is happening. There's a pre-sell list, and I'm not sure we qualify, but of people who are ready to basically go live. And by the way, we didn't really talk about this either, Pat, but there is some actual planetary considerations. We spend a lot of time talking about climate change and sustainability. Like, we have an Earth that we don't quite know where we're at in terms of physics and meeting its capacity and the resources. And there are people out there really in this group and around your ecosystem that are really trying to solve for what do we do?
Yeah.
Well, they're calling it an extinction event.
So. Well, so who knows? But here's what's right. But here's what's really interesting. The best way to learn is to look at orbiting bodies like the Moon and other planets like Mars. And so we are supporting the Mohammed bin Rashid Space Center right now today, who has a satellite orbiting Mars, who's taking samples of the atmosphere to help us understand how Mars was created, as it could relate to the Earth's atmosphere, and we're supporting NASA's rover, Perseverance rover, on the surface of Mars right now today. They're bringing all their data back and analyzing it on AWS because our systems could analyze and distribute the data faster than their on-premises capabilities could do it. So it's just fascinating the kind of things we can learn.
So go ahead.
No, I was just going to say, we could talk to you a lot about the philosophical stuff. And by the way, I love that because it's just a little different than our typical, 6.5 content.
This does require market education. This isn't something that people fully understand. And I think, the general public is even fascinated by this now. And, companies, landing booster rockets and watching, failed attempts before. People are back into space now. I was born in the 60s, not in the 50s, but the fascination seems to be back, and
I think so.
And there has to be this re-education of the possibility, as opposed to some space race for the Cold War.
Right? Well, and that's why making life better here on Earth is so important. Better understanding our environment and our atmosphere. I have a thesis, by the way, about what you said about space. People paying attention. Here's my thesis. You tell me if you agree. Space is cool.
I mean,
there it is. There you have it, right?
Yes.
Space is cool, and it just captures our imagination. And we're just at the tip of the spear of what we can do. When you bring people with deep space expertise, and at AWS, we've built a large team with expertise across every part of the space mission, from launch to design to on-orbit operations, me included. And when you couple that with our deep cloud experts, it really lets us do some innovative things.
All right, so I want to bring this back to the cloud for a minute because that's where we started. And as we sort of get towards the end of this, you had an announcement here. I mean, something kind of cool, something kind of exciting. And by the way, something I think our audience will really understand.
Absolutely.
Yeah.
Talk about what you announced here.
Yeah.
And about the significance of it.
So happy to do that, and thanks for the opportunity. So here's how I will set this up. The world has come to understand the value of the cloud, right? Terrestrial here on Earth, we're using the cloud for everything, and businesses know they need to be on the cloud or they won't stay competitive or successful over time. And so we've learned all that. And at AWS, one of the things we've done is we've developed a pretty good track record about pushing the cloud to the edge.
Right.
Everybody needs cloud, including remote, disconnected, disadvantaged users, mobile, remote, etc. And so we've built the edge of the cloud, pushing the cloud to users rather than bringing users to the cloud, because it saves them money, reduces their latency, improves their ability to innovate. And so as we see the space industry grow and all these space missions, we have recognized that we have to move the cloud closer and closer to our customers. And in my case, that means moving the cloud closer and closer to space, and that means moving the cloud into space. And we are happy to announce this week we've been working on this for a year. We launched it back in April. We're just now kind of coming out from behind the black curtain, but we have partnered with Axiom Space and NASA, and we took a snow cone, which is a commercial off-the-shelf edge computing device that you can get right now today for your edge computing needs, and we went through the full NASA flight certification, shock, vibration, acoustics, all the things that you do to get a flight qualified box, and we qualified this for flight. Axiom put it on their AX-1 mission, which is the first all-private astronaut mission to the commercial space station. They took the snow cone with them. We pulled it out, we hooked it up, we turned it on, and we ran a sophisticated machine learning model to it to do object detection inside the International Space Station to document the 25 experiments that Axiom and the astronauts were working. So what we did essentially was we just demonstrated the ability to do edge computing, storage, analytics, compute on orbit, in space, on the International Space Station for the first time ever.
It kind of redefines the whole definition of edge computing. I mean, you can't
It really
get that far.
does.
Well, and it's not. We're not talking about some smartphone-based compute device. There's 14 terabytes of
14
storage
terabytes.
that are available. That and doing the crunching and phoning home.
That's
to
right.
the AWS cloud
When you need
required.
to. When
By the way, hold
required.
that thing up because we
Yeah.
have a camera here. So,
So,
this isn't it. This isn't the
5 pound.
one from the
This
mission,
isn't
but
the one, but it's
close.
identical. All we
Right.
did is take one off the shelf, which is fascinating. We may make some modifications in the future because there is a big customer demand for this,
But
right?
it's great. You built it off the shelf. You took an off the shelf product and got it certified for space. So it also means
did.
you're building some pretty robust gear over
It
there. at
says a
AWS.
lot about the ruggedized application of the snow cone for sure. But I'll tell you, we went through a lot of work to get it flight certified. It was a 7-month process to get it flight certified, and rightly so. There are human beings on the space station, and we didn't want to endanger that, but we passed every one of them. And what's really exciting now is we've got medical research companies who tell us that they would run a genome sequencing experiment in microgravity to the point we talked about earlier,
Right.
and then they would spend the next 18 hours downloading
Exactly.
the data. And so they'd run an experiment and then log off for 24 hours until they got the data back. Now, with one of these on orbit, we can crunch all that data and do that analytics in about 20 minutes. And so from 24 hours to 20 minutes, we've increased by 20 times the amount of science time available on the International Space Station. And so this is really, we believe, this ushers in a brand new era of innovation in space and cloud working
Dude,
together.
I totally want to get to space.
No, I totally
I'm in.
too. Can you get
Sign
us
me
on the
up.
list? Do you know anybody?
I know some people, but I'm gonna try to.
I wanna
sign
do-
up
I wanna do
before
a
you. I'm
follow-up
just gonna
pod
be
with you
honest,
in
as long
space.
as I'm signed up ahead of you.
You go to space, we'll pod from space, and then we'll use the snow
Deal.
cone to be able to get it back to Earth, and so
Deal.
we can stream it live.
We'll do the video editing.
We could
on the
absolutely
snow
do
cone.
that. Absolutely do.
No, I love it. And what I'm really struck overall too is about the private-public partnerships in this
Yeah.
new generation of
Yeah.
space.
Yeah.
Amazing things were done the past 40, 50 years, but I've seen this acceleration where public companies and government get together
Yeah,
and,
I love
and make it even better and
love it.
compress time, just like you're talking about compressing time and results.
We did this in
for
5
this.
months,
And
7
that
months.
is just completely amazing. And also, this isn't an announcement that says you're fixing to go to space. This is actually on the ISS
We are doing
right
edge
now.
cloud computing in space right now today.
And I think that's cool.
And by the way, it's still on orbit.
Yeah.
We completed the first experiment, and we are open to do follow-on experiments with this box on the International Space Station right now.
It's exciting stuff.
Well, listen, the future is bright. It's exciting. I mean, it's been so great to spend some time. Like I said, it's
My pleasure.
for me. I did grad school. I went back. It's like it was almost like PhD in a weekend.
Right.
And I might just put Dr. Daniel Newman. There's probably someplace I could sign up that will send me that certificate, right?
There you go.
But in all seriousness, learned so much. So many smart people. Some really just great energy here, Pat. And I gotta say, reMARS. We're going to do this again. Like,
Come on back.
This is not the last time.
Come on
This
back.
may be one of the coolest shows. And if you're out there, this is one of those things like probably should be checking this out, because whether you're in the everyday grind of, being a CIO, a CTO, you're a semiconductor, software, hardware, this is kind of like, what are we doing this all for? And this is kind of the aggregate here, robotics and AI. This isn't about robotics and AI. It's
And
about
it's how
what's
they all
changing the
integrate,
world.
by the way, right? So I'm the S part of Mars, right? But this is all about how we integrate all of those, because everything I just described has robotics and artificial intelligence and automation involved in it. So yes, we are moving here at AWS. We are moving the cloud into space, and it will create a whole new era of space innovation.
Technology. Go ahead.
Yeah, so Clint, let's stop. This is a good place to stop here. We just want to thank you for coming on the 6.5 on the road at reMARS, and we are talking about space. Let's do this again sometime.
My pleasure. Thank you both
Take
for
care.
being here. Thank
Great
you.
to have you.